In this video, I'm going to continue with transforming the transformation of non-parent functions, and in this specific example, which is example 3, I'm just continuing with the numbering system that I had before. I'm going to transform a non-parent quadratic function. So let's start off with this. So let's say, for example, I have some function f of x, and it's equal to 2 x minus 1 squared plus 3, okay? And I'm going to transform it to g of x, okay? And basically there are 3 transformations in order to go from f to g, and they are the following. So it's a reflection over the x-axis, and then there is a stretch in the y direction by a factor of 3, and then I'm simply going to translate by 2 and -1. All right, and the question as always is find an expression for g of x. All right, so let's start off this way. We have our f of x. Well, it's already in vertex form, which means it's factored pretty much already for us. So it's x minus 1 squared plus 3. Actually, you know, the way I'm going to write this is going to be 2 times, if you paid attention to the last video, I'm going to just put a 1 there, and it's going to say x minus 1 squared plus 3. That 1 really makes no difference, but we'll see how that does play for us in the very last step. Oh, and before I start actually sketching that, the thing I want to emphasize is a reflection over the x-axis. The way that's written in functional notation is a negative f of x, and a stretch in the y direction by 3, well, that just stretches all the y's, so it's going to be 3 times f of x. This is not going to play any important factor right now, but at the very end, when we're trying to find g of x, this will become important for us. So anyways, let's start here. So once again, let's just draw our x and y axes, and then sketch this. Basically, yeah, something like that. Great. So first of all, we know it's in vertex form, so the vertex is 1, 3. It's 1 over here and 3, and it's facing up, and it's facing up. All right, so this is our original f of x, nothing fancy here at all. So the first thing that we're going to do is we're going to reflect it over the x-axis. So if we're going to reflect it over the x-axis, what that means is all the y's change, so the x's don't change. So this 3 will become -3. So this will become -3, and it faces down. So it just faces down that way. And what I'm going to do is I'm going to erase the other one. So I do it step by step. So I'm going to erase this one. Oh, and I should have just kept that one, but I'll just keep that one in blue. So that's a 1 right there. All right, so we've taken care of the first thing, which is a reflection over the x-axis. Next, a stretch in the y direction by 3. That means all the y's get multiplied by 3. The x's don't. So this -3 will now get multiplied to -9. So what I'm going to do is first, let me just stretch this line over here a little bit. All right, so there we go. So since it's going to be moved to -9, say this is -9. Obviously, it's not to scale, but all I'm just doing is just giving you an idea of what it looks like. Oops, let me just move that up a bit. Yeah, there we go. So it's -9, and I'm going to erase the last one. So there we go. So that's -9, and I've taken care of that one. And then finally translate 2 to the right and 1 down. So 2 to the right and 1 down. So if I translate this 2 to the right, it's going to be to 3, and then 1 down will be to -10. 10. So it's going to be 3 and negative 10. And it's going to go down like that. And yep, okay. And I'm just going to erase the old one right there. All right. So now that we have that, so basically this is our g of x. This is our g of x right here. And let's now figure out an expression for g of x, because that's what we want. So let's write the original f of x. The original f of x was equal to 2. And what I'm going to do is I'm going to write in this form like here. So it's going to be x minus 1 squared. I'm going to put a 1 inside here. Oops, no. Sorry, the square should not be there. It should be, I'm going to close bracket and put the square outside here, and plus 3. I just copied this over here. Now, for g of x, I'm going to write that in blue. G of x, all right. I'm sort of going to copy the same format. I'm going to put something like this and put a square out there. The thing is, we know that this has been moved 3 to the right, because g of x is 3 to the right. So this is going to be x minus 3. And it's down 10, so it's going to be minus 10 over here. So our goal now is to figure out what the coefficient is going to be inside over here and inside over there. Well, that's where what we wrote in green is going to become very helpful. So there's a reflection over the x-axis, which is obviously going to affect the y's, so it's going to be negative, and a stretch in the y direction by 3, and that's obviously going to affect the y's, and we're going to multiply it by 3. So all we're going to do is just affect the y's. We're not going to affect the x's whatsoever. So in effect, we're going to multiply all the y's by negative 3. So what's going to happen here is that this 2, because it affects the y's, is going to be multiplied by negative 3. And since this 1, which affects the x's, there is no sort of change to the x's, that's simply going to be multiplied by 1, because obviously if there's no change, it becomes itself. So 2 times negative 3, well, that's negative 6 over here. And 1 times 1, that's equal to 1 over there. So the final thing that we're going to write, because obviously we just can't have that 1 over there, the final thing I'm going to write is simply the negative 6, all right? 1 times that is itself, so it's simply, 1 squared is simply 1. So really it's not going to affect anything. So I'm just going to write x minus 3 squared minus 10, and this is g of x, and we are done. All right, so that's basically how you write that over there, and obviously this makes sense because since it's negative, it's facing down. It's definitely stretched by a factor of 3, so obviously compared to the 2, it should be stretched by 3, and we've already taken care of the transformations over here, and that's done over there. All right, and so that's our final expression for g of x. And in the next video, I'm going to show you one more example of this. In other words, transforming non-parent quadratic functions. See you in the next video.